Next, we've got John Guibas, co-founder of Succinct Labs. So, welcome.
Hey everyone, I want to give a big thanks to the organizers for organizing this amazing event. But yeah, I was a student here, so it's also great to be back on campus. But yeah, I'm one of the co-founders of Succinct, where we've been working on various ZK applications on Ethereum. And this talk is really a reflection on what we've learned over the past year and why we think personally that the next 10x in ZK comes from coordination. So to give some context as to why ZK is super interesting, I mean, you might have already gotten this from some of the previous talks, but there are these inherent physical limits to the EVM that sort of prevent developers and users from getting the applications and the security properties that they actually want from the main chain. And to this end, ZK is kind of like the ultimate holy grail precompile on the EVM, because what it can do is it can compress an arbitrary amount of computation on the EVM down to just 200K gas. And the main way that we've seen that this property being utilized is through the proliferation of ZK rollups, such as Starkware. But there's another class of applications, in my opinion, that are pretty interesting to explore. And in particular, these are applications of ZK that sort of augment existing state transition machines on Ethereum. And I think in the past year, we've sort of seen a growth in sort of these applications on chains such as Ethereum and existing rollups. And in the case of Succinct, we actually spent the past year working on building light clients for certain ecosystems, such as Ethereum, Celestia, and Avail. And light clients are a great use case of ZK because essentially, verifying a light client on the EVM would have normally been impossible, right? You'd have to verify hundreds of these validator signatures on curves that the EVM doesn't support. But basically, where ZK can come in is it can compress this huge computation just down to the verification of 200K gas. And it's really nice because on Ethereum mainnet, you actually want access to this data, or you want to bridge tokens from these chains to these chains. So it's really useful to have these light clients on an existing chain instead of launching a ZK rollup just for it. And I think beyond light clients, there's been various other teams that have been working on super interesting applications of ZK, such as storage proofs, accessing historical state. Modulus presented on how they're working on ZKML. And I think we're just starting to see the emergent properties of what ZK can do to on-chain applications. And I think if you zoom out a bit, with how much progress we're having in ZK, it really feels like we're having sort of a Moore's Law of ZK moment, where it really sort of, if you extrapolate just a bit further, it really feels like we're only at the cusp of what's possible when building new novel on-chain applications powered by limitless compute. Despite this, I kind of feel like it's been surprising that we haven't seen many more applications on-chain that leverage these properties. If you actually do some analysis on-chain on when the ZK precompiles are used, compared to the usage of ZK rollups, we really barely see any meaningful usage beyond these few use cases that I've mentioned. So one question I want to answer in my talk is, why haven't we seen more adoption of ZK and decentralized apps on Ethereum? So the first reason, which might be quite obvious to many of you, is that most app developers today just don't think of ZK as a tool that they can use in their toolbox. And this has to do for a lot of reasons, but one of them is that some of them think of it as this moon math. And even to understand what ZK is at the highest level, you sort of have to get over these abstract theoretical new ideas, such as idea what a proof is, what verifying a proof is, the parties that are involved in this process, such as the prover and verifier. And I think it takes time for these developers to learn these new abstractions. And let's say that you're able to get over this bottleneck of learning these theoretical things, but then you encounter that writing circuits often requires you to learn completely new programming models than what you're used to when writing normal programs. And beyond that, there's all these weird terms being thrown around like witnesses or writing your programs and constraints. And I think all of these things prevent dev app developers from thinking about ZK as a tool that they can actually use. And if you can get beyond these challenges, you write your circuit, you want to deploy it on chain, I think something that we've realized at Succinct, and I think a lot of other teams have also realized, is that deploying these ZK applications on chain is just a huge infrastructure nightmare. And at Succinct, we wrote this circuit in a few months, But we actually realized that that was only 20% of the work that it took to actually deploy a ZK app to production. The reason for this is that there's so much work that goes into writing the contracts that connect your circuits to your EVM application. You have to build off-chain actors that are able to watch for requests for proofs and respond to them, or schedule the proofs when their end applications need them. You have to solve the problem of the fact that your circuit might be deprecated in a few months because of consensus changes or other changes that your end users need. And it's really annoying to manage these circuit upgrades and governance logic. And beyond that, there's just like some problems I think teams have with economies of scale, where it's sort of you have to invest a lot of work into building scalable, cost-effective proof generation. And another big pain point for a lot of ZK companies is that you have to put a lot of work into making sure your off-chain actors are really robust and have really high availability. Because for a lot of the end consumers of these ZK dApps, because the proofs themselves provide security, the end game, or the final layer of security that's needed is actually availability, which is super critical for a lot of DeFi applications. So what these challenges have kind of resulted in the current ZK market is that most dApp developers today, when they have ZK needs, what they essentially do is they outsource them to existing ZK companies or ZK teams or ZK professionals. And I think this is really reflected if you think about all the ZK apps that are being built today. Most of them are built by teams who are themselves ZK experts. And I think this is also largely because you have to be a well-resourced team to be willing to invest all of these resources into building the off-chain actors, the contracts, and even in the case where you want to build a proof aggregator, it takes a lot of work as a team to your app basically has to have sufficient demand to justify building these things. So my controversial take maybe in this talk is that I think this current model of how dApp teams outsource their ZK needs to other ZK professionals is really unhealthy for the ZK ecosystem, and I think it results in various negative externalities. And in particular, what I mean by these negative externalities is that I think sort of this current model of how we outsource work to these ZK teams inherently leads to less useful and meaningful adoption of ZK in decentralized apps. So the reason for this is that I think with the current way that things are structured, when dApp developers want to use new ZK tools, they experience really bespoke SDKs and APIs for integrating with different ZK stacks. Essentially, the way the market has converged is that there's these really monolithic ZK architectures where the ZK people have built these giant systems that involve the contracts, off-chain actors, the circuits, the provers, and basically your dApp is the final piece in the puzzle, and you have to make sure that your piece actually fits in. And this can be super annoying if you're using two different ZK service providers. It can be really annoying if you want to switch from one ZK provider to another ZK provider because all the work at the end is involved in figuring out their interfaces and connecting with them properly. The result of this is that dApp developers, in my opinion, fundamentally have less flexibility when they're trying to use ZK in their apps, and they become super reliant on their ZK vendor. At Succinct, we've experienced this multiple times where we have this ZK-like client circuit for Ethereum. And the really powerful thing about ZK is that because it's a succinct proof of computation, if there's additional computation that the end customer wants to use in their ZK proof, it would actually be really nice to be able to add a few changes to your circuits even after it's already deployed. And the way this usually works is that they realize this while trying to integrate our system, and they DM us over Slack or Telegram, and they're like, yo, why can't, can we stuff this in there? Or can you change it to output this thing in a different format? And I think basically this coordination that's done over Telegram and Slack is super inefficient for both sides, right? The dApps basically have to bet or be willing, are basically making a bet that you're going to support their specific use case. They're basically making a bet that you're going to make the changes in the smallest amount of time that they need. And on our end, we have to manage these one-off integrations, and it's super annoying and it causes a lot of mental overhead. So I think beyond that, what's even more problematic is that I think the current way that this is set up essentially encourages technological centralization and prevents adoption of the best ZK tech. And the reason for this is that if you're an end dApp developer and you're thinking about using a specific ZK service, you actually might choose a company who doesn't have the best circuit purely because they have better infrastructure. In other words, you're basically choosing the company that has the best sum of all the different parts that lead to a production ZK app. But in my opinion, in a truly efficient market, it really feels like end dApp developers should use the best circuits for their task, They should use the best infrastructure for their task, and they should use the best contracts for their path. And I think inherently it feels like there's just a lot of friction to adopt new, interesting, and better systems. So I think the result of all this is that the current ZK landscape has a really slow cycle of innovation for dApps, and it slows the progress toward the adoption of endgame and new proving systems. So at Succinct, we've been thinking a lot about this, and we have a different vision that we think, an alternative vision for ZK that we think is possible. So our vision for the future of ZK is that we think developers will actually be smart enough and that they'll be able to write their own ZK circuits. There's going to be a lot of need for education for developers to understand these new ZK concepts, such as proofs and verifiers. But on the programming level, we think with circuits and SDKs and the proliferation of ZK VMs and ZK VMs, we think that ZK-enabled compute will become greatly accessible. The second thing that we think is super important in our vision for ZK is that we really have to encourage the properties of permissionless innovation. The properties of permissionless innovation are inherently what allow for new novel dApps to be created, and it inherently accelerates us towards more cost-effective proof systems and cost-effective infrastructure. And I think historically, if you think about it, it really feels like we're so early in ZK. There's new proving systems every month, and I think this was reflected in some of the past few talks, but it feels way too premature to make single isolated bets on proving systems on specific circuits and infrastructure stacks. It feels much better if we can basically choose and pick between the proving systems that work best for our application and do with that. And I think another thing that connects really well to that previous point I made in my slide is that I truly believe that there'll never be one proof system that rules it all. I think that right now there is sort of this idea maybe that in the end game, everyone will be using some sort of ZK VM, but I actually don't think this is true. I think circuits will actually always be more lightweight, and for deterministic computation with like fixed length, circuits will actually always be an order of magnitude cheaper than most ZK VMs. And I think there's a bunch of other cases, such as with Modulus, where they're doing machine learning. Maybe there's specific things they can do there to optimize the proving system. If you're building cryptography applications that operate over a specific curve or a specific field, it might make a lot of sense to build proving systems very specific to that use case. And I think even in the VM landscape, we're starting to see where there are some ZK VMs that are built with basic instruction sets and some ZK VMs that are built specifically for the EVM. And I think we'll start to see this where the ZK EVM specifically built for the EVM will inherently always be faster. So from the dApp developer's perspective, we truly think that ZK, they should be able to write their own circuits and without vendor lock-in to black box centralized providers. We think that they should be able to easily use the right proving system for their use case. We think that they should be able to fork existing circuits and add additional complexity when they need to. And we think that we should build a system that allows dApp developers to take advantage of the latest advances in ZK technology without any friction. So when thinking about all these challenges and the goals that we want, at Succinct what we realize is that what we need is a coordination around a standard for ZK proofs. So to this end, what we're working on is something called Succinct X. And Succinct X is essentially a vision for the end game of ZK. And we think that in this vision, the world will look like a world where we have many open source, community-driven SDKs for building ZK circuits so that dApp developers can write ZK circuits directly. The second thing that we think is super important is to build an ERC-like standard for requesting any statement to be proven in any proving system on the EVM. The third thing that we think is an important part of the puzzle is to build an open market for proofs that essentially drives perfect competition for the most cost-effective and highly available proof generation. Now, this was pretty dense, so I'll now go into each part and decompose it. So in the first part, I really want to emphasize how we think it's really important that the open source community starts to put a lot of effort into building these SDK circuit Lego blocks with the aim of them being consumed by end dApp developers. And because of this idea that I brought up many times of how different proving systems are better for different proving stacks, we think that the underlying coordination layer has to be agnostic to the implementation and design of these different SDKs. And then when you're a ZK dApp developer, you should basically be able to choose whichever proving system or VM is best for your use case. The next part of the story here is that dApp developers really need to be able to have a consistent interface when consuming different ZK services and dApps. So we're essentially trying to build a smart contract standard that basically makes it so that dApp developers don't have to learn new interfaces and new APIs when interacting with different circuits. So one moment, a dApp developer could be using Halo 2 for a signature verification circuit, but in another moment, they could be using a ZK Wasm VM to prove GPT-1, and it'll always be a standard that they're very used to, similar to making a call on Ethereum. The result of this is that we're now going to be able to build an open source platform where developers can essentially upload ZK circuits for dApps to use, and dApps essentially will have the property that they'll always be able to use the best proofs with absolutely no vendor lock-in. If in 2023, our light client is the best implementation of an Ethereum light client, but next year another open source implementation of a light client comes to the game, then dApp developers should really be able to switch from these two implementations with just one parameter change in your contracts. And that's the vision that we're trying to build towards. The final thing I want to touch on is how this open prover market is a super important critical piece of building a cost-effective and highly available prover system for dApps. Basically, what we're trying to do is have strong economic guarantees such that if there's at least one economic rational actor in the market, then the provers will always be available. And essentially, another great thing about this system is that it has a lot of analogies to MEV markets with searchers and builders. The reason for this is that because proofs, at the end of the day, with the proof, all you care about is that it properly verifies. And that means that the protocol doesn't have to make any opinionated decisions with how the proofs were generated. And what this means is that now you can drive perfect competition on different proving hardware, different proving hardware, different like proving infrastructure, different proving like nodes and how it's hosted in the cloud and stuff. And basically, what this does in like traditional economic terms is it drives proof supply up, right? And inherently, what this can also result in is in more induced demand for ZK proofs. And we think that this is super important for driving novel adoption of ZK. Finally, I think from the dApp developers' perspective, I think when they use this platform, they should really feel like they're not getting worse guarantees than if they were to run a prover at home, which is something we truly want to encourage. So to zoom out a bit on these three things, I really want you guys to realize that what Succinct X is building is sort of a coordination layer that coordinates informal activity that already happens in the ZK ecosystem today, right? The circuit developers already build proving infrastructure. The dApps already coordinate with the circuit developers on Slack and Telegram over the apps they want to build. And essentially what we're trying to build is standard and interoperability layers so that all these parties can communicate with each other and work more seamlessly. So our end goal with Succinct X is not just to make ZK better and faster, but really think that we're only at the tip of the iceberg in terms of what's possible with building ZK-enabled decentralized apps. And I think even though we've only seen a few applications so far that are pretty interesting, our hope with this is to really encourage people to build new, novel, interesting dApps that, in the end, encourage more adoption of Ethereum. And yeah, the main point here is, like the next 10x in ZK, we think, at Succinct, comes from building a coordination layer that coordinates between all parts and parties in the ZK pipeline. So if you're a dApp developer, feel free to hit me up after this talk, or you can go to one of our workshops at ZK Social Club this week. We'll be previewing a preview of what Succinct X is and how you can use it for building ZK applications. But yeah, that's pretty much it. We're building fully in the open source, so if you want to contribute or work with us, please let us know. And yeah, please reach out on Twitter or Telegram if you're interested. Thank you. Are there any questions?
Hi, John. As a dApp developer, I think you talked a little bit the pain points as I'm learning ZK painfully.
Oh yeah, thank you. Yeah.
And, I just wonder, like, what's your practical roadmap for Succinct? I can be your roadmap.
Yeah, I think it's pretty similar. It's both. I think we're trying to do both things. I think in the end game though, like we're trying to be like super unopinionated. So I think it could become something like ERC, and it could just become like a new protocol that emerges or even eventually gets internalized by Ethereum itself. So I think, yeah, we're trying to be unopinionated with how it sort of comes out. But I think both the Hugging Face thing and the smart Open Zeppelin type approach are both what we're trying to do. Yeah. Yeah, I do believe so. I think, yeah, a lot of this is motivated by like the past year of working with a lot of these circuits. And I think what we've realized is if you build really good libraries, you don't have to think anymore in constraints. You just think in terms of like operations. The only mental bottlenecks become like thinking about like deterministic computation versus variable length. But I think for those types of workloads, ZK VMs just make it so much easier, and they make so much more sense. Yeah, I also think with ZK VMs, I think the proving time does seem expensive, but relative to on-chain costs, it's honestly like not that much. So I think there's a lot of room for both approaches. Yeah.
I was just wondering, so in doing this platform approach, it becomes kind of putting this on a platform they don't control. How has the reception been, or have you just started to talk with people about, is this something that a lot of people in the ZK space want to try to coordinate around?
I think our vision is the dApps fully own the IP of their circuit and the proving and everything. Like we're just trying to be like the middleman who coordinates the communication between the parties. And I think a lot of times when we talk to dApps, they don't feel like they're giving us anything. We're just providing like the software standards and the communication for them to get what they want.
Yeah, to be clear, I was talking more about the people in the ZK space who are developing, different parts of the infrastructure and
I see.
being in a Succinct X marketplace versus, or coordination platform versus doing something of their own.
Well, I think in the end game, all of this is open source software. And I think it is truly a positive sum game if we can all engage in building these like positive sum systems. Like I think one thing that wasn't mentioned here is that if we can all coordinate on one layer, it actually gives us the opportunity to aggregate all proofs together. So I think in some ways, although I think some existing people might feel resistant to this idea, I think in some ways it's also inevitable. Yeah.